So this is your B tree structure, right? Where you have all these are all the pages for indexes, and then you have separate pages for data. Okay, so we don't worry about data right now, how the data is stored. So the indexes, let's say if you're looking for, if you're making an index on employee ID column from 1 to 290. Okay, all right, you make an index on employee ID column. So the data is stored in here. Okay, everything is in here in these pages. But when you create an index, it makes an entry to the index pages. Now, how does that entry makes to the index pages? How does that entry is created? So what it's going to say is, let's say it divides employee ID from 1 to 100 on page 1 or page 2. Okay, so let's say this is your page 1, the one in here. This is your page 2. This is your page 3. This is your page 4. And then you have more. Okay, so we don't worry about it. And then let's say you have page here in 111, then you have page here is 112, and then 113, 114, and 115. So this is the structure that always gonna followed in the B tree structure. When the index are created, there is a page at the main level, then intermediate level, and then the root level. Okay, so this is always the structure. So what it's going to do is, on the first page, it's going to say information about employee ID 1 to 100 is stored on page number 2. Okay, all right. On page number 2, when you go, it says, okay, the information so it has, let's say, more information in here because you have 290 employees, right? So in here in second row, it's going to say from 101 to employee ID 200 is in page 3. Okay, and then 201 to employee ID 290 is in page 4. Okay, so that's the information only stored in here. But do you know, if you're looking for page number, if you're looking for, let's say, employee ID 150, where you will be going next from with this information? You will be going on page 3. So page 3 has further information about, okay, any employee ID between 101 to 150 is on page, let's say, 12. Okay, any employee ID from 151 to 200 is on page 13. Okay, so it stores the information like this in here. Now you started with here, which employee ID you were looking? 150. So you go to page 3. On page 3, what information it finds? It finds the employee ID 150 is where? It's page 12. So it's going to go in here, and there will be all entries that I'm making right now. It will be always available. It's not going to create the entries. The entries will always be there. So when you go on page 3, it says, okay, let's say employee ID 101 to 110 is on page number, let's say 1152 or something, okay, which is in the database. And then 111 to 120 is on page number whatever, okay. It has all 1153, I guess, okay. And then it keeps saying, for all the, for what's the range in here, it has to say until 150. So let's say it says 141 to 150 is on page number 1156. Okay, it's on page 1156. So now it has all the information. So this is just one page we covered. The same information will be in here for 1 to 100. Okay, and then 1 to 100 will be in here. So now let's say if I just do it once, so it's gonna go from top to bottom to find it. Either it can go from here to page number 3, or it can go to page number 2, or it can go to page number 4, based on which information are you looking. Okay, then from here, either it can go in here or it can go in here, right? So these are the pages information that it has to take you further down to divide, you know, the employee ID is divided into the groups, and then you look for, okay, employee ID 150 I'm looking for, you go page number, okay, I'm going to page number 12, and the page number, let's say for employee ID 150, it's on page number 1156. So from here, you're gonna go to page number 150 in your database, and you're gonna look on that page, which has from employee ID 141, 142, 143, 44, all the way to 150. So it has to, in here, it has to look through all the records on the pages until it finds 150. So now you don't have to go through all the pages. So let's say this information about 1 to 290 is in about 100 different pages. So instead of going, if you don't have the index, you have to go through all the 100 pages in order to find the employee ID 150. Okay, let's say. But in here, how many pages did you go through in order, when it's indexed, how many pages did you search in order to 4? 1, 2, 3, and 4, right? The actual page. So in this way, you have, when you have the index created, it optimizes your query. So it doesn't have to look through all 150 pages. It just looks through the page which has the information. So all it goes through the indexes. So now if you have lots of content, if you create indexes on all the columns, there will be so many index pages which has information about everything. And now when it has to go through all those pages, it will be a lot of information. And I told you in the last class, it's just not finding the data. When you insert the page, when you insert the data, when you delete the data, this index needs to be maintained. So let's say if you add more data in here and you created employee ID up to 1000. So you have to make those entry from 291 to 1000 in all these index pages, right? You have to make changes. Let's say if you delete employee ID from 150 to 150 to, let's say, 170, you have to make this, all the changes in the indexes that accommodates that those employee ID doesn't exist. You know what I'm saying? So that it doesn't happen that, oh, you're looking for employee ID 160 which is deleted, and if it doesn't delete from the index, you're gonna go and you're gonna say, okay, it's 160 is on page 3, it's on page 12, and if you go page 12, it says, okay, 160 is on, let's say, page number 157. You go in here, you don't find that record. That doesn't make sense. So that's why the index has to be updated every time when you make any changes. So the indexes doesn't come for free. It has to be maintained for the records if you're inserting, deleting, updating the records. Okay. If you make a primary key employee ID, it's indexed in the index pages like this. So let's say if the employee ID is your primary key, it automatically becomes a index, a clustered index. It becomes automatically not just the index. There are two types of index we talked about, clustered and non-clustered index. So the employee ID becomes the clustered index, and it automatically does an entry in here when you create a primary key. Not the foreign key. The foreign key doesn't make an entry. Just the primary key. All right. So I hope everybody saw the video. Anybody have any other question on the videos that you watched? Was it confusing? Or anyone have any other question? So all you're trying to do is you're trying to avoid a table scan. If you don't have an index, what you're going to do is you're going to scan through all the records, right? So same thing, the table scan is same as book scan. If you don't have table of content in your book, you have to scan through book until you find that particular chapter, because there is no information that chapter is on which page. So what you're doing is scanning a book, basically. You go through and keep finding that's scanning a book. So the same thing in here, it's a table scan when you don't have an index. So that's why you make an index and it becomes a index scan. Okay. All right. So now let's say on the employee ID there is an index created. When you created it as a primary key, what you do is you use the employee contact table. You use the employee table and you use it on contact ID a lot. The same table you use it on contact ID as well every time. So either you use on this one or on this one, most of the cases. So, but you can have index only created on one column, you're right? The clustered index cannot be created on more than one column. So what do you do when you have to create an index other than the primary key column? Okay, so the primary key column automatically comes with the clustered index. How about if you want to create one more index on the contact ID? Can you create a primary key, can you create a clustered index on the contact ID as well? Yes or no? Can you create one more clustered index? No, you cannot, because clustered index is only one. So it's same as primary key. You can have only one primary key on the table. In the same way, you can have only one clustered index on the table. So now what would you do if you have to create an index on the table? What you're going to do is you're going to create a non-clustered index. Okay, so if you have a non-clustered index, only the difference is that the data is not physically sorted by contact ID in the table. It will be sorted by whatever is your primary key is, or the clustered index is. So in here, do you see the sorting is done by contact ID? No. Even if you create an index, it's not going to sort the data by contact ID. It will be sorted always by employee ID, where you have your clustered index. So if I change my clustered index from employee ID to contact ID, it's going to sort the data for employee in ascending order. Okay, so let's see where do I have a table called employee, and we're going to see how to create an index. So first we're going to see how to create a clustered index. Okay, so if you create a primary key, it automatically comes with the clustered index. But let's say you don't have a primary key, you just want to create a clustered index. So in here you have an employee ID, but is it a primary key? No. So if it's not a primary key, it doesn't come with index. Okay, so there are probably other indexes that is created on the table, but let's delete these ones. Okay, it's all created by me. Okay, all right, so right now the table doesn't have any of the indexes. So if I do right now select the data from table, when I say employee ID equals to 1, what's going to happen? If you're looking for, let's say, employee ID equals to 150, what's happening? It's doing a scan. So what we're going to do is we're going to look the query plan. Okay, so let's see, I'm going to do a query plan. So see, in here it's showing it's a table is scanned. Okay, it means there is no index on the table. Now the table scan, I just told you what is table scan, right? So how you can avoid the table scan is you create an index on the employee ID column, because you know it's a unique key that is created in the table, and it's a unique key and it doesn't have the records duplicated, right? It's a primary key. I mean, it's not a primary key, but it's a key that you can create an index on. So what I'm going to do is I'm just going to create a new index and say I want a clustered index on the table. Okay, so when you right click and say index clustered index, it says what do you want to call this column. I'm going to say it as clustered index. You can leave it as is, and you're going to say on the column on which I'm creating, I'm going to say employee ID. So I know when I look at clustered index, it's created on employee ID column. And is this column unique? Yes, the employee ID is unique in the table. So you can check this one, and then all you need to do is you need to add the column that on which you want to create an index. So I want to create a clustered index on employee ID column. I click OK. I click OK. See, the clustered index on employee ID is created. So see, when I ran the table, it was scanned, right? So let's do. So now what it's saying, instead of table scan, it's saying a index scan. So what happens is when it says a clustered index in here, when you're trying to find out the employee ID 290, where does it go? It goes through. So in here it was a table scan, right? So let me close this one, and what I'm going to do is I'm going to do open this and run the query. So now in here, do you see it says a index seek, right? So it means when it says index seek, it means it's looking for the index when you're looking for employee ID 150. So what it's doing, it's doing the same thing that I just explained. When you're looking for employee ID 150, it's going through this and going to that. So it's not doing a table scan where it's going through all the pages. It goes from index here to here to here, and then it goes to the record page directly. So that's why it's called as an index seek, and that improves the performance when you have the index seek. Why it's index seek? Because you have created an index on the table. Okay. All right. So now let's say what I'm going to do is I'm going to change my index. So before I change my index, let me run the table. Right now the data is sorted by which column? If you see in here, it's sorted by employee ID, right? It's sorted by employee ID. Now let's change the key from employee ID to contact ID. What I'm going to do is I'm going to rename this column as contact ID, and I'm going to change the key by going into the index. So I rename the index and I go inside and I'm going to change the key. So I double click, it opens up. I'm going to remove the employee ID and I'm going to say I want to create an index on contact ID instead of an employee ID. Okay, I add that column, I click OK. It says the index is recreated. All right, so now let's say what happens when I run the select statement. See, when I run the statement now, what is happening? Do you see the difference? Is employee ID any more physically sorted in the database? No. Now the contact ID is physically sorted. So that's why when you create an index, the data is physically sorted in the database, physically stored. When it's stored, it's physically sorted. So that's why now you see the employee ID is in the ascending order, and the contact ID, and the employee ID is scattered. Now there is no order for employee ID. Okay, so when you create a clustered index on a table, you can have only one clustered index because it's a physically sorted data in your table. So that's why, because you cannot sort both of them together at the same time, you cannot have two clustered indexes. Does it make sense? Any questions? All right, so let's say now what do I do is I made a clustered index on contact ID, and I like the, I want the, because I know I use the contact ID more often than employee ID, I leave the clustered index on contact ID. But I also know I use the employee ID as well a lot. What can I do now? I cannot create a clustered index on employee ID, but I have an option to create a new index that is called as a non-clustered index. So non-clustered index doesn't physically sort the data. It means when you run the query, it will always be sorted by contact ID. It's not going to sort the data by employee ID. That's the only difference. So in here, you can have a non-clustered index created on the table, and you're going to name it as non-clustered index employee ID. Okay, and you say I want to add a key which is employee ID in here. Click OK. Click OK. The index is created. So now when you create a non-clustered index, it also makes an entry through here, through the index page. So now on index page, you have entry for both employee ID and contact ID. So whenever you look the data by employee ID or contact ID, it's going to go through the pages, index pages, and going to find the detail level of data. Okay, so what I'm trying to say in here is you can have multiple indexes on the table when you need. It's just not one cluster index. You can have multiple non-clustered indexes on the table. Okay, but try to avoid too many indexes. So that's how you're going to create. Now if you have to drop the index, all you need to do is select the index and click delete. It will ask you, are you sure you want to delete the object? Click OK. The index is deleted. Okay, so creating an index as a clustered or non-clustered, it's very simple. You go in index, clustered or non-clustered. These are the things that you won't be doing usually. It's all done by the DBA, so you don't need to worry about creating index, maintaining an index. But I want to make sure that you know what the indexes are and how those work. So when you see an index, you know what it's doing. You won't be playing much with the indexes though. But it's always good to have ideas so you can further learn about things when it's needed, you know. Okay. Any question about indexes or any question about the video that you saw for the practice? All right. No questions? Did Victoria, did you see the video? Glishan, did you see the video? Okay. All right. So, okay. So try to watch that video. It's going to help a lot to understand about the indexes. I mean, we talked already, but it will go in brief. I mean, it will go in more detail. You're going to have a good idea. Okay. So now the next thing, so we have learned the objects which are tables and indexes in the database, right? Now we're going to talk about stored procedures. Now what is stored procedures in the SQL Server? The stored procedure is nothing but it's a container or a wrap. It's a wrapper for your SQL queries that you write. So what you do is when you write your queries and you want the queries to be used every day and you don't want to write that query every day, what you're going to do? So let's say if you have a query with 5-6 joins that you use it every day, what you're going to do? You're going to go in here and you save the query, and then you come next day, you open the same query you saved and you run it. That's the one way of doing it. What would be the other way? I mean, is this the efficient way? That's not the efficient way because you wrote the queries. So let's say we all work on the same database. Okay, we all use the same query. I don't know what Adan has written, I don't know what Victoria has written for their daily purpose. So the things are not getting shared between the developers, right? If you do like that. So, or if the things are that routine things that you use every day, you want to store that on the server instead of storing it on your local hard drive. So that's one of the advantage, but there are bigger advantage than what I just talked about, not saving. There is a plan advantage that we're going to see in the stored procedure. But basically, when you are writing the queries, you write all your queries that you want to run every day, and you put it in a container, and then you say, okay, this is my stored procedure inside which you're going to put your queries, and you can save it that on the stored procedure would be saved on the on your database. Okay, so anybody can access those who have the right permissions can access those stored procedures which are created by anyone. So now, what does the stored procedures, what are the advantages of stored procedure, why do you create it, what it can do? So the stored procedure can have any of the commands you think of in the SQL that we learned till now. You can have select, delete, insert, update, alter, drop. You can, with the stored procedure, you can do any of these inside a stored procedure. Okay, so then the second thing is, when you have to run a stored procedure, so where does the stored procedure resides in your database? So if you go and you look for programmability, in here you have all the stored procedures. Okay, you have all your stored procedures in here. Now when you have to run this stored procedure which has set of query, which has like your select statement, how do you run the stored procedure? All you need to do is you need to say execute stored procedure name. So let's say if you have a query which is like 5 joins and everything, you don't need to worry about running everything. All you do is you just say execute stored procedure name. The stored procedure has a special command to run. It goes with execute. You cannot say select stored procedure name. Okay, the select doesn't work with stored procedure. The stored procedures are only run by execute. Okay, so they are independent and you can execute to run the stored procedure. Okay, all right, so you don't select the stored procedure, you execute the stored procedure. All right, now what is the another advantage of having a stored procedure? The security. So let's say when you wrote a code and you store it on the SQL server, you can give the permission who can see your stored procedures. Okay, it has security things that you can control who can see your code, who cannot. Okay, instead of putting it in the drive, let's say you don't want to share that when you store it on the SQL server, you don't want to share it with everybody. You can have the security around it. Okay, so it's a secured, the stored procedure can be secured, so no one can see if it has like special codes or something that doesn't need to be shared with everybody. Okay, all right. So when I have seen people who get confused with what is stored procedure and what is function. The functions are totally different from stored procedure. It is also a container and a wrapper, but it can only do select statement inside the function. So when you write a function container, inside that only query that you can mention is select, but stored procedure can come with any of the statements. Have anybody used functions till now? Do anyone use functions in SQL since we started? Have you used functions? Sorry? When did you use it? Any example do you remember you used? Yeah, going right. Yeah, all those were functions. Perfect. Good. So you use the function when we started our class. In our first or second class, we started using functions. We used date functions. We used aggregate functions, right? We used convert function. We used get date function, right? So we used a lot of functions. So you know how to use the functions. It's just you don't know how to create those functions when you need. So till now we were using the system functions, right? We have seen all these table functions, scalar function, system function. We talked about the aggregate functions, string function, date function. Okay, so you know how to use the function. It's only thing is now we're gonna learn how to create those functions. So you know how do you use the function? You always use the functions in the select statement. This function, the stored procedure is with execute, and then the functions is with the select statement, right? When you say I want to run a function, you say select function name. Okay, so it's used with the select statement. All right, it can only have function inside the function container. You can only do a select statement. You cannot do insert, update, delete inside the function. Okay, all right. So now why do you need a function? Do anyone remember about what would be the advantage of having a function? The function helps you if you are repeating the same calculation over and over. You want to put that logic in your function, and you call that function, right? So you don't need to worry about doing same thing, writing the same expression over and over. All you do is you say, okay, function, you pass your parameters, and that's it. You can put it in the select. And if you want to use it in the where condition, it's just you say function, calculate, pass your parameter, and do the condition on it. It helps you, the function helps to make the query cleaner, and then the expressions are more exact. So it avoids the error and that kind of thing. So it can be used for derived columns. It reduces the effort for writing the same expression over and over when you're doing the functions. Okay, right? So I mean, I just wanted to make sure when we are talking the stored procedure, we say at the same time we talk the functions, at least because you used it, so you know the difference between stored procedure and function. Okay, now coming back to the select statement. Whenever you write a select statement, there are 4 steps happening in the SQL Server. What are those 4 steps happens? Have you ever seen the SQL gives you an error when you write a select statement, right? You have seen that. It does it so many times. When you do something wrong, it gives an error. So whenever you write a code and you execute, it does 4 steps before it shows you the result. What are the 4 steps it does? The select statement, when you execute it, it does parsing. What is parsing? Parsing checks if you have any syntax error in your SQL. If you spelled select wrong, if you spelled from wrong, or if you spelled where wrong, something like that. Where is the syntax error? Not the table name is incorrect or not. The table name incorrect, it doesn't matter when it's parsing. Okay. Now, second, it does the bind. When it does the binding thing, it makes sure the table exists in the database. The columns that you mentioned in the select statement, it exists. The columns that you mentioned in the where condition, anywhere in the object, wherever you're defining the objects, it's gonna check those object exist in the database. So that step is called the binding, and it's gonna make sure that the column that you mentioned is in the in that table. So let's say in from you say one table, and then the select has a column which is coming from different tables. So that's not correct. So SQL checks those things at the step 2, which is called bind. So there is a parse, and then there is a bind, which makes sure the object that you have defined in your select statement or from statement, where, order, by, anywhere, it can bind properly. Okay, so once your SQL statement is correct, then it does prepare the plan. Now what is the plan? We have just seen when we were trying to run this query, if you check this option which says include actual execution plan, you click that and you execute the query. When you execute the query, it shows you the execution plan. So the execution plan is nothing but how your query can be how can the SQL Server engine show you the result in a quicker way, so you don't have to wait forever to see the result for your query. So that is the plan. So it's very similar to the GPS. When you put an address from point A to point B, what does the GPS do? It gives you the optimized route from going from one place to another, right? So you don't have to worry about it doesn't give you all the routes, or it doesn't take you the longest route. It tries to optimize it. The same thing SQL Server engine will do when you're running the query. It try to optimize the query so the result can be can get fast. Okay, so that's where it prepares the plan and it checks, okay, what route should I take to make sure this is done quickly. Okay, so it prepares the plan. All right, and then the fourth step it does is execute. So once it knows it have to go from point A to B with minimum resources and quicker, then it executes that plan. Okay, so these are the 4 steps involved in your select statement: parse, bind, prepare, and execute. Now every time so let's say if you're running the select statement over and over every day, you come in the morning, what's going to happen? Does it has to do all 4 steps every time, right? It has to parse, then bind, prepare, plan, execute, right? It has to do all these 4 steps because what you did is you saved the select statement and you're running it every day in the morning. So the SQL has to do all 4 steps. Now how you can avoid and make the query smart is by converting that query that you use in the stored procedure. You convert that query in the stored procedure. When you convert that query in the stored procedure, once you convert it into stored procedure, what does it do is it only parse and bind your query when it creates the stored procedure. It doesn't have to check it every time. So these 2 steps are only done once when you create a stored procedure. It doesn't have to do every day. So let's say when you're created a stored procedure, it's done, and you're running it every day, these 2 steps doesn't need to be done. What about the 3rd step? What SQL Server will do is it will store the plan in the memory of your system. So let's say today you execute the stored procedure, it will take the plan and say, okay, this is my stored procedure name and this is the plan for this. I'm going to store it in the server. So think about it, doesn't have to find the optimized route for the same query every day. So all these 3 steps are skipped when you are running the stored procedure every day over and over. All it does is execute because it knows these 2 steps are done and I have the plan in the memory, so it goes in the memory and gets the plan, boom, done. It doesn't have to prepare the plan every day and find which is the optimized one. So when you have the stored procedure converted to the stored procedure, it does not need to go through all the steps that are necessary. So think about, it's just not faster with here. I mean, it's just not that you have stored the procedure on your system, you also made it faster to run faster, right? So whatever times you used to take in here in your select, it's no more there when you have the stored procedure. So that's a very important interview question asked. What are the advantages of stored procedure? Why do you make a stored procedure? Where does the plan get stored when you create a stored procedure? It gets stored in the cache memory of your system. Okay. All right. Okay. Now there are 2 types of stored procedure: parameterized stored procedure and non-parameterized stored procedure. What is parameterized and what is non-parameterized? Do anyone remember? We already talked about it when we were doing the functions. We talked about parameterized functions and non-parameterized functions. So it's now more different than what was in the function. So do you know function takes input? If the function takes input, it's a parameterized function. If the function doesn't take input, it's a non-parameterized. So the same thing, if you pass a parameter to a stored procedure, it's a parameterized. If you don't pass anything to the stored procedure, it's a non-parameterized stored procedure. Okay. All right. So in 2 types of stored procedure: parameterized and non-parameterized. Now let's see, before creating a stored procedure, we have seen this in the yesterday class, last class. You can declare a variable. A variable is nothing but that stores the value for what you want. So let's say you declaring a variable which is the data type of int. It means this variable can store integer. Okay. So what you're going to do is, if you have to find out what's the product ID for my bearing ball. So what you're trying to do is, from the inventory table, you find out what is my inventory for bearing ball. What is my inventory for bearing ball? what you need to do, you first need to find out what is the product ID for bearing ball, right? So you go in product table. Let's say you are doing like this. You go in here and you say, give me the product ID for bearing ball, which is 2. You put the 2 in here. So every time you have the product name changing, the product ID is changing, right? And you have to supply it in here. So if you don't want to do that, like take the product ID from here, put it in here, what you can do is you can store the product ID in a variable which is called add product ID. It's a variable you can store in that, and you can use that product ID in here, okay, by storing in here. So what I'm going to do is I'm going to declare a variable, okay. Once I declare a variable, I'm going to store the product ID in this variable. So now what I'm going to do is, instead of changing every time 2 to 3 to 4 to 5, all I'm going to say is whatever is stored in this product ID, use it for this product ID, right? So I'm saying, okay, what I'm saying I declared the variable which is integer type. For the select query, this is the new thing that we are putting in the select, okay, select X. So this is your query that gives you product ID. Now what I want is I want to store this product ID in my the variable that I created. So I'm going to say product ID variable is equals to product ID. So it's going to store this product ID in here. Once it's stored, you can use that variable in your second query, so that every time whenever you change the name, you don't need to worry about changing the IDs in this from here, okay. So if I run this query now, the whole thing together, I'm getting what is the inventory for the bearing ball. So if you change the name in here for the other, you're gonna get that product inventory. So think about now why I'm telling you this. So let's say if you have a company, and in the company you have a customer care center, and you get a lot of calls about what is the inventory for bearing ball, or what is the inventory for this bike, what is the inventory for this cloth, what is the inventory for this accessories, what is the inventory for this mountain bike, touring bikes. What are the inventories you have? You get this customer care gets so many calls. They don't know the SQL, okay. They don't know the SQL. All they do is they have the front end application from where they say they go in the application and they say, okay, they choose the bearing ball, and boom, they get the data back. How it's gonna happen? So you have to write a code on the back that does those things. So all the customer service representative gonna do is it's gonna pick what object the customer is asking for, and they should get this thing, you know, the result. What is the location, what is the shelf bin and quantity, whatever information you want to give it to them, okay. So how do you achieve that? What you're gonna do is, because you're gonna convert this thing into the stored procedure, and the stored procedure will take a parameter bearing ball, and then you will be running this thing in this type, the stored procedure. Only these things will be passed by the customer representative. Every time he will be passing the different name, and all you're doing is running this query in order to get the data for different product, okay. So now how do you convert this thing into the stored procedure? Let's see that. Before that, any question? No, it's just a comment. No, it's a comment. If it's a comment, it doesn't include it. Yes. Yes. So right, so you're storing whatever the value for this product ID from your table into this variable. You store it in here, so that you can use the same variable in here, you know. So whatever value will be stored in here, you're going to pass it again to this table, so that you can get the inventory for that product ID. So you're passing back this product ID. Yes, right. This is the variable add product ID, which will be storing the value for product ID. So basically the variable is using to pass the value around from one table to other table. So you store the value of product ID into the variable, and then you take that variable which has a stored value and you pass it to your another query, the stored value inside the product ID parameter to here, or to the variable, basically variable or parameter. Yes. So let's say if you have the product ID is a value which what would be the value set to the product, this variable, whatever is coming from this product ID, right? So let's say this comes as 2. So what do you do is you save this 2 in this variable. So the 2 gets saved in here. Now you're looking from the inventory table, and you know you're looking for inventory for bearing ball. Do you have bearing ball in here? No, but you have the product ID too. So all you need to do is you need to say where product ID equals to what? Equals to 2. And 2 is stored in which variable? It's stored in this variable from here. So you use that variable to pass the value. So this is just your where condition. Instead of putting the actual value, you're storing it in this, and then you're passing it here. So you first save the value into the variable, and then you take that value from the variable and use it in your next query. Okay, so now let's create a query that is parameterized query. Okay, so how do I create a parameterized? So you have this query that you use every day to find out the inventory. Okay, so all I need to do is, in order to create a stored procedure for this, I'm gonna copy this code. Okay, in order to create the stored procedure, all I need to say is create. You know how to create the table, right? How to create the indexes, or how to create table. So you say create. This time what are you creating? You're creating a procedure. So you say create procedure and the name of the procedure. What do you want to give the name of the procedure to? So when I'm creating something, I'm gonna do is say the name of the procedure as whatever, SP, which is stored procedure. So I know by looking at the name it's a stored procedure. SP underscore product inventory. Okay, product inventory. So create procedure name. Now, do you pass any value to this procedure? Yes or no? Are you passing anything to the stored procedure? Yes, you are passing the name of the product. So you say product name. Is that what you are passing? What's the product name looks like? What's the data type of product name? What is the data type I use in here? What's the data type for alphabets? Either varchar, right, or character, or varchar, anything. You can use any of those, right? So I say varchar, and then I say, okay, my product name will be no more than 100 character that I will be giving it to my procedure. Okay, so I say @product name variable varchar 100. Okay, now all I do is say as and begin. Okay, begin and end. So this is the wrapper that I was talking about. Begin and end is just to show you everything goes inside in this one. So you say create procedure name, all the parameters that you're passing. If you're passing more than one parameter, you just put comma, and then you keep creating the parameters. Okay, if you have multiple parameters, and after that you say as, it means you're saying this is my procedure, starting in here, the syntax. So all you do is you put that code that you have written before inside the begin and end. Okay, all you do is you put that code in here. Now where do you getting the bearing ball from the user, and will it be changing every time? So if it's changing every time, do you want to keep this as a bearing ball, or you want to replace it with the product name? You want to replace it with the product name, right? So that I'm just going to comment it out. It means it's no more a part of code, and you say @product name. So all you did is you make one more variable in the name. You're going to take the name from where? From the user. Okay, so this procedure will be passed with the parameter product name, and that name will be stored in this variable and will be passed in here instead of bearing ball. That's what you're going to keep change every time to get the inventory. So that's it. Once you put the code inside whatever you have written, it will do the stored procedure. All you need to do is write a container and then execute this procedure. So once you say, okay, create the procedure, and then you execute the whole thing, it will create a procedure in the database. So if I right click in the adventure works, I'm gonna see this procedure in programmability because I created this in the adventure works. So I say stored procedure, and here, where is the one that I just created? Product inventory is the one that I just created, SP product inventory. Okay, so now once you create the procedure, what do you need to do? Every day you come, you just need to do is you need to say execute, and then you take the procedure name from here, and then you say I want to run it for bearing ball or whatever. You pass this. So this is your parameter that you're passing it to the stored procedure. So execute is used for stored procedure. So execute procedure name and then the parameter that you have to pass. How many parameters it takes? It takes only one parameter, which is product name. So I'm passing the product name to the procedure. I select the query, I select the stored procedure and run. It's giving me the bearing ball inventory. Okay, so if you change the name for the product, you will get, so let's say if I don't know the product name right now. So if I get the name of the, if I know, select star from production.product. So all you need to do is you just need to keep passing all the names that all you have for the inventory, whatever you're looking for. So if you're looking for adjustable race, you put, instead of ball bearing, you pass this, it gives you that. Or if you do BB ball bearing, it's give inventory for that. So all the customer representative will be doing is you give this procedure to the front end guy, and he will be passing this value, and then this information will be showed to the user. Okay, so you created your part, and now all the front end guy who is developing this website, he will take this procedure and calls the database with this procedure, with the parameter, whatever the customer representative will select. So now let's say the new requirement comes in, and they said, okay, you are showing me all this information, you know, what do we want to do is we don't want everything from here. We just need the location ID, shelf, bin, and quantity. Can you get away with all these information that we don't use? What do you need to do now? You already have the procedure. All you need to do is right click and say I want to modify my procedure because I want to take the column out, right? So what do you do when you have to modify the procedure? All you do is you right click on the procedure and you say I want to modify the procedure. So when you're modifying the procedure, all it does is uses the alter command. It uses the alter command. Instead of create, it says alter procedure name. Okay, and then all that things you had. Okay, so instead of create, now it's alter. What do you want to alter? Do you want to show all the columns? You don't want to show all the columns. All you want is you want few columns, which is shelf, location ID, bin, and quantity, right? So you put all the column names instead of everything. Instead of star, you mention the column name, and now you execute the procedure. So you change the procedure. Now whenever the customer representative will be running this procedure, they're gonna get only these information. Okay, so that's how you're gonna create the procedure, alter the procedure. Now let's say this procedure is no longer used in the company. They want you to get rid of it. All you need to do is you can say drop procedure name. Either you can do that, drop procedure name. You can say just proc as well. Procedure or proc is fine, either of them. Okay, once you do that, it's gonna drop the procedure from the database. Okay, if you run this, or you can right click and say I want to delete this procedure. Click OK. It will get rid of the procedure that you had in the database. Once this procedure is gone, if you don't have the code, you cannot retrieve it. Okay, So once it's dropped, it's gone. So what is the procedure right now? I mean, what you're seeing is it's nothing but all the statements that you have learned till now. Doing a select, if you have to insert the data into the table, if you have to create the table, or if you have to update the data, if you have to delete the data, you can do inside this begin and end block. It could be anything huge. It could be 100 lines of codes in here that would be just selecting from one table, then aggregating the data, then updating some data in the aggregate table, and then doing the filtering. So it can go step by step. Okay, but the stored procedure is nothing but it's a container that can have a code inside, which will be doing a several steps. Okay, so in here it's doing just 3 steps. You can have 200 steps to find something. Okay, so the stored procedures are long, but don't get scared with, oh, that procedure is huge and I don't know the stored procedure that big. The stored procedure is not big. If you know the logic behind select, insert, update, delete, done. It has nothing to do with the huge stored procedure or the small stored procedure. If you have the concepts clear about DML, DDL, DCL, that would be good enough to read any huge stored procedure. Okay. All right. So let's see. What do I do is, let's say you deleted the stored procedure, but they said, okay, they want the stored procedure. When you pass the name to the stored procedure, can you do is you can add one more parameter to the stored procedure so that they can pass the quantity to the stored procedure. Okay, so when you are giving the information from the inventory table for any of the product, we also, let's say when the customer calls in and they're looking for certain inventory, they're looking for 300 quantities, they're looking for 400 quantities. So what the customer representative want to do is he wants to pass the name and the quantity for the product. Okay, so the customer representative says, okay, give me only those locations where I have this product which is more than or equal to the product quantity I mentioned. Okay, so let's say you store the product ID is right now stored at only 3 locations, but let's say you store it in like 100 different locations. Everywhere in each state you have like 2 or 3 locations. Think about that. So now when you're looking for that particular when customer calls in, you only want to look those places where quantity is greater than that, because if the customer is looking for 400 quantity, you don't want to look the places where you have like 30-40 quantities in like 30 different places or 10 different places. Okay, so what you're doing is you want to pass now 2 parameters to the stored procedure. One is the name and second is the quantity. So what do you need to make changes? What do you need to make change to this query so that it will only show the quantity passed by the user? You need to say and quantity greater than or equal to the quantity passed by user. Let's say if it's past 400, you say 400, right? If it's past 500, you say 500. So where this 400, 500 gonna come from? It's gonna come from the parameter that you have to create so the user can pass 2 input parameters to the procedure. And you're gonna say the quantity is the parameter that I'm creating next. What's the data type for quantity? It's an integer. So you say @quantity integer. So you can have multiple parameters separated by comma. Once you create this, where this quantity will go from, whatever the quantity is passed, it needs to be passed in here, right? So instead of 400, you're gonna just say quantity. So the quantity will be given by the user as an input. Okay, so now you're creating the procedure you don't have in the database. Okay, if you have this procedure in the database, you cannot recreate it. So I create it, execute successfully because I deleted the proc. If I try to execute again, I'm gonna get an error. This proc already exists. Okay, so you cannot have the same procedure create twice. Okay, so now when you're running the procedure, all you need to do is you say execute and then you say procedure name, and then what is the first parameter now? So if you look in here, you're gonna find the first parameter is product name, second is the quantity. So you say, and then you say the quantity, which is 500. So if you do this, you're gonna get, maybe there is no, so let's say if I do 50, I get all the location, right? But if I say, okay, I need only those where I have at least 401 product, so I get only one row. So see, with just this query, you can run the whole thing that you have the code in there. Okay, so you can have multiple parameters. You want to say, okay, I need only those ones where the location ID is, you can mention your location ID. I'm looking for this particular location ID or the name of the location. You can do built on that. So what I want you to do is when you go back, use the same procedure and try to say user, try to input one more parameter as the name of location. You have to get the location ID like you're getting, so you get the name of the location from the procedure, but you have to find the location ID and you have to add an AND clause in here where location ID equals to coming from the location ID variable. Okay, so you take it as a location name as an input parameter, and then you have to make changes. The location name is not in this query, so you have to first find out what's the ID for the location provided by the user, and then you can put it as a condition in here on location ID. Okay, try doing that as a practice. Now let's say they came with the problem that, you know, this works great, everything is good, but sometimes the user calls in and they just want to know if we have the inventory for that product or not. They are not looking for any quantity, they just want to know whether we have the inventory for that product. They're looking for 1 or 2 quantities, let's say, or like they don't worry much about the quantity. So can you make this parameter optional? So if I pass, then it will do the comparison. If I don't pass, then it doesn't do the comparison. What would you do? So can anyone think about what would you do if you have to make this parameter optional? How would you do that? What you need to compare in here in the quantity when no. So what do you need to do in pass the quantity value when the user doesn't define it? What the quantity should be? The quantity should be greater than 0, right? If the user doesn't pass the quantity value, you want to make quantity 0. If he passed, take the value what he passed. So you're gonna say is, okay, if the user doesn't passes, I'm gonna default it to 0. So if when you say is equals to 0, if the quantity value is not passed from outside, it will be taken as 0. Okay, so what you're making is you're making this parameter optional. If this value is not passed, you will make it 0. So try it now. Can you do it now without passing the value? You cannot do it because the quantity is a parameter which is required right now. Okay, so what we're going to do is we're going to make it optional by saying equals to 0 when not passed. So the SQL server knows that if it's not passed from here, I can make it 0 because you said that in here. So what you need to do now to the procedure, can you create this procedure? No, because the procedure exists. So all you need to do is instead of create, you need to say alter procedure name. You execute it. All right, so now the quantity has a default value of 0. So now when you try to run this query, see, it runs. Why? Because there is a default value for quantity. You don't need to worry about. So if you want to mention the quantity, you can just say comma 400. Now it's going to honor what you're passing the quantity. Okay, and if you don't pass, it's just going to make it 0. Okay, so now you have a procedure with optional parameters. Okay, so these are the variations that you can have in your query. Okay, or you cannot have anything. You cannot have anything. You cannot have any parameters, which is without parameter, which would be simple. You're running the query with no parameters you're passing inside. Okay, that could be the another thing. So let's say you don't do any parameters, which means you can just directly run the stored procedure. Okay, so you have to remove these parameters basically, and whatever your logic for the query is in here, and when you execute the procedure, it's going to give you the result. Okay, is that clear? Any questions? No. Okay, so before we go to parameterized, non-parameterized, we just seen it. We have seen how can you make the parameter optional. You can run for it, and then we have already talked about the union and intersect except. Okay, all right. So that's what I have for the stored procedure. So the stored procedures are basically, it will help you to create a wrapper around your code that will help to get stored on the SQL server. It doesn't store only on the SQL server, but it gives you the advantages whenever you are running the stored procedure over and over every day. It doesn't have to do parse, bind, prepare for the queries. It directly gets the data from the memory and run that procedure. Okay. All right. So try come in the next class with that. I want you to do the location as a parameter to this location name you're gonna pass, and you're gonna make the location based on the location ID. You will be doing it. Okay, so if the location name is passed, you will be filtering on that. Okay. Try adding parameter location name. Okay. All right. So now the next thing we're gonna see is the functions. Okay. What are the functions? So we talked about function. The functions are nothing but the same thing as you can use those in the select statement. Those are also the wrapper for your query, but it can only have select within your wrapper, within your function. It cannot include anything. Okay, and it can only use with the select. So this, you cannot say for the stored procedure select. Okay, that's not gonna work. So the same thing for the function, you cannot say execute. The functions only runs with select statement. So this is one of the function. There's a system function that you can call with no parameter, right? So the functions works with the select statement. All right. So when you create a function, what you will be doing is you will be trying to say, I have certain calculation that I want to do, and I want to create that calculation as a function. Okay. So whenever I call in my query, that function can be applied to that particular data set or to the row as a derived column. Do you remember how we did like the function, and you were deriving a age? So you can have an age function in your database where you say give me the birth date and I'm going to give you the age. So let's see how can you create a function for the age. Okay, so you know how to you know the use of the functions, how to use in the select. So what we're going to see is how to create a function for age. Okay, so let's say you calculate the age every time based on the dates, based on the birth date. You do that a lot, so you need a function for that. So what, instead of like defining that select date difference between date and that two dates, you just say I want to create a function. I don't want to write that date difference function every time. So what you can do is you can create a function. How do you create a function? You say create function, create function and the name of the function. So I'm going to say this as an fn. So I'm putting this sp and fn, so I know when I look at this thing, it's a stored procedure. Function is an abbreviation, fn is an abbreviation for function. So I know this is a function. Okay, so I know I can use it with fn is only goes with select, as sp goes with execute. Okay, so I'm creating a function fn underscore get age. Okay, so this will give me an age. So when you have to calculate an age, what is the parameter that you need to get from user, which is the birth date. So you're gonna say give me your birth date, and what would be the data type for this? Date time, right? for the birth date, it would be the date time, or you can just ask for the date. Either one is fine, right? You don't need to worry about much time because you're not gonna give them like your age is 66 years, 3 days, 2 minutes, 1 second, no? So you can just be with the date. The precision for the age is just the years. You don't need to worry about anything else, right? So you say create function name, the parameter. It's very similar to how you create a procedure. And then you say as, and then you say begin, and then you have end. So again, this is a wrapper for your function. All you need to do is you need to put your code in here. Okay. So instead of when you create procedure, you said create procedure name, parameters, as, and then begin and end. In between, you're going to write your code. So do anyone remember what was the function that you used to get the age of the person? How would you do it? How would you find out if you know the birth date? How would you calculate the age? No one? I think with 6. Yeah. Yes. What do you do to the birth date? You subtract the year of your birth date from the current year, right? Okay, year birth date is nothing but it's stored in this parameter, right? So you're gonna say add birth date. Now what do I do? Year of get date minus year of birth date. That's it, right? And then you're gonna say age, and then we'll make a date time for now. So that's, and you're gonna say as this as age column. Okay, so you're gonna get year of birth date, and you're gonna subtract from year of get date, right? This would be your age. So if you create the function which has your logic to find out the age. Okay, all right. So in function, we haven't done a few things. So when you say create function name, you need to say you're gonna return this thing. Okay, so the function works a little different than we haven't put the complete code in yet. So you need to say return in here. Okay, return as an integer. Okay, so not integer. What would be the age? It would return as an int, right? So you're gonna say this function would returns int. Okay, so you're gonna create a function name, and then you say it returns int, and then you have to say this would be your age, right? So either you can declare a variable that stores the age first. So I'm gonna say declare, I'm gonna say declare variable name age, which is integer, and I'm gonna say what I'm gonna do. I'm gonna store, I'm gonna get rid of this. I'm gonna store the age in my variable. Okay, so I'm gonna store age in this variable that I just declared, and I'm gonna return this. So whatever you have to give back from the function, you have to mention it into the return. So I'm gonna say I want to return this age to the user. Okay, so select the function can return only one thing. if we have multiple select, you cannot return everything. The function will allow only to return one out of all these things. Okay, so create function name, then you're going to say return int as begin. You have your logic, and then you have to say return the whatever you want to return. This in here I want to return age. So in here you say returns, and in here you say return. The difference is returns will define what would be the output of your function, whether the function output is integer, it's a date and time. In this case, when you subtract the year from both of these, it will be a number. So you say it's an integer, and then you say return age. So returns defines this function is of what data type. This function is an integer data type. Okay, because it's always going to return an integer. Okay, all right. So if you do this now, you have the function created. Now how do you call the function? You say select and function name, right? Select function name, and what do? You pass the birth date. So let's say if I pass 01/01/1988, oops, not 1888, I meant 1988, you're gonna get the age of the person. Okay. All right. So now you can get the age of the function. Sorry, age of the person. So all you need to do is you need to pass the birth date, and you can find the age of the person. So what you can do is, let's say if in adventure works where you have from human resources.employee, right? You want to find all the employees' age. What you can do, comma star, let's say if I do this. So when you do this, what you want to do, you want to find out the age for each of the person. What you can do, you can just have the birth date in here, and you can pass that birth date. So now you don't have to write the logic for birth date, finding out the birth date. The logic is inside the function. The function is going to calculate the age for you when you pass the birth date. So for all the employees, it's just going to calculate the age for you. So you say run this query, it executes, and it gives you the age for each of the person based on their birth date. So see, now you don't need to worry about writing the logic for this one. It's inside the function. So this is a simple logic. When you have complex logic, when you're trying to calculate the percent, when you're trying to do certain complex expression, you don't need to worry about expression. Like every time you have to have correct expression. Everything is in the function. You just call that function, you pass that the value as a parameter, and then it does the calculation for you. So it avoids lots of complexity and then the miscalculations when you have the functions. So it makes the thing standard. The way it needs to be done, it makes it standard. Okay, so that's just one example. You can have, so let's say you want to find the retired age of each of these person. You can write a logic in your function, and you say this would be their tentative retire date. So let's say the retire date is when they become 60 years. Okay, when they become 60 years. So from the birth date, you're going to find when they will turn 60, and you will calculate you will add that age to their birth date, and you can have the retired date from that. Okay, so you can have any kind of calculation that you want to do on the table, either to calculate the retired date or the age, or if you're doing on the sales table, if you want to find out. So in here, I mean, we have seen all these examples. I'm just repeating. Sales order detail. You want to find out sales order header, maybe. You want to find out. So this is the order date, and then you want to calculate the statement date. So the statement date is nothing but whatever the order date is plus 30 days. So you can have a function that adds 30 days to this column. You can create that function as a statement date, and that the statement date would be nothing but you just pass the order date to your function, and that will add 30 days to the order date, right? So now the same thing you can have is, if you have more than one parameter, you can just keep adding the parameter in here in the function, and you can have multiple parameter function. or if you don't need any parameter from the function, you don't need to pass anything. You just leave this as you don't need it. You just say function, create function, function name, and in here the returns type is the important. The return type would be, let's say if you're returning, let's say if this function returns the statement date, which is nothing but 30 days from this date. So what is the data type for this column? When you're returning the statement date, the data type would be date and time. So in here you need to change, let's say what you need to do when you will be creating a function for fn get statement date. Okay, you're creating this function and you take the order date as an input. You say okay, create function statement date, and what this will be returning, this will be giving you the statement date. So it has to be, this function will return what? It will returns date and time, right? So you can have, you know how to do, you know how to get the, add the 30 days to it, right, to the order date. So you're gonna say select date add, and I'm gonna do dd comma 30 comma to the order date. So this is the function we have seen. All you're gonna do is you're gonna declare a variable, declare, and you're gonna say I'm gonna declare the date variable, which is statement date as a date time, and I'm gonna store the statement date which is coming from here into the variable, right? And then I'm gonna return this variable to the user. So this will become your function. Now let's say in here you want this 30 to be optional, it needs to be come from outside. So what you can do is you can make this as a parameter, and you can say the interval for statement date, how far do you need. So this will become the interval as a parameter in here, right? Okay, and what's the parameter data type? Is an integer. So you say you take two parameters from the function, the order date and how long interval do you need to generate the statement date. So let's say based on the certain criteria as you determine your interval. So now it can has two parameters, interval and the order date, which will, I mean, it's gonna return the same thing, the statement date, but certain people can have statement days for 1 month, certain people can have the statement date for 12 months where there's a promotional going on or something, I don't know. So that time you can have multiple. So same way you can have, if you're returning something, the order number or string, then you can have the data type as character. Okay, so it depends on what you're returning from the function, the data type would be, returns would be that. Okay, any question? So the function and the stored procedure are very straightforward. It's just you need to think about how you're going to create a wrapper. You need to know what would be output for my function, what would be my input for the function, and then all in between is just the logic about creating your expression in the function with your select statement. You can only use select inside the function, you know that.